Good morning everyone. Today we will learn about the topic operational amplifier. This is the table of content which shows introduction, pin diagram, circuit symbol, equivalent circuit model, ideal and practical characteristics, inverting and non-inverting amplifier, and applications of op-amps. Okay. So to start this topic we require some prerequisites like basic knowledge of algebra, linear equations, integration, differentiation, Ohm's law, Kirchhoff's law. Okay. So after ending the session, we will able to learn about the fundamental principles and operation of an op-amp, describing its internal structure and functioning. We will able to differentiate between the various op-amp configurations such as inverting and non-inverting amplifier. Coming to introduction part, it is a high gain voltage amplifier with differential input and a single-ended output, characterized by their ability to amplify the difference between input signals. That's why it behaves like a voltage controlled voltage source. Now, why it named as an operational amplifier? Can anyone tell me? Okay, I'll give you the answer. Since it performs various mathematical operations like addition, subtraction, multiplication, differentiation, integration, that's why it is named as operational amplifier. The following figure shows the pin diagram of the op-amp. From the diagram we can say that it is an 8-pin IC, and this figure represents the circuit symbol of op-amp, and this figure represents the equivalent circuit model of op-amp, in which input resistance Ri is the very high input resistance, ideally infinite, and output resistance R0 is very low resistance, ideally 0 value, and the output voltage is equal to A times the input voltage, where A is the open loop gain and Vd is the difference voltage given as the V2 minus V1. Here is a comparison of ideal and typical practical op-amp amplifier. From the table we can say that ideally open loop gain of op-amp is infinite, but practically it's very high. This is the inverting amplifier. Why we called as the inverting amplifier? Since the output is 180-degree phase shift with respect to the input, that's why it is called as the inverting amplifier. In inverting amplifier, positive terminal is grounded and input is applied at the inverting terminal. That's why it is called as inverting amplifier. From the concept of virtual grounding and by using the KCL law, we have calculated the gain, which is equal to V out by V in, and we will get this minus Rf by R1. So coming to the non-inverting amplifier, in this amplifier input is applied to the positive terminal and inverting terminal should be grounded, and from the concept of virtual ground and the concept of KCL, we will get the expression of voltage gain as 1 plus Rf by R1. Okay, and coming to the application part of op-amp, following is the application: comparator, integrator as a differentiator, adder, subtractor, voltage follower, logarithmic amplifier, and this is the numericals which you can solve. So this is the next numericals. Now coming to the conclusion part, it is an amplifier which is the essential components in the modern electronic circuit, renowned for their versatility and wide range of applications. If you have any doubt, can raise. Thank you.